All right, there is 1, 2, 3, and 4. I know that Crystal wants to see number 3. Other than number 3, do I have any requests? Whoa, whoa, whoa. We're on 4 there, sister. No. Okay, we're still here. You still want to see 3?
Yes.
All right. All right. Again, bring everything you know about math to the party. If I gave you this, that's a highlighter, you idiot. If I gave you this, what would you do? Distribute. So, doesn't this look like distribution? X cubed times x is x to the 4th. X cubed times x to the negative 3 is plus x to the 0. What's x to the 0? Plus 1. X to the 4th is 1/2. So it is 1/2 to the 4th plus 1, which is 1 over 2 to the 4th plus 1, which is 1 over 16 plus 1, which is 1/16 plus 16 sixteenths to get 17 sixteenths. Good? Excellent. Hey, I found my good coffee cup. I know you were all worried about it. Five. H is already highlighted in pink because people had trouble with it. Number F. Okay, elementary school teacher. Because they're always saying number F. All right, so F was our first one. A cubed, b to the 1/2 over. Now, this is out of order, so I'm going to put it back in the order that we like. 2 times 3/2. The 2 and the 2 cancel, leaving me with a cubed, yes? A cubed over a cubed cancels, leaving me here. 1/2 minus 3. B to the 1/2 minus 3 is 6/2, right? 1/2 minus 6/2 is b to the minus 5/2, right? Which is 1 over b to the 5/2. And write each as a power and as a radical. There's the power. And as a radical, it's 1 over root b to the 5th. I like to hear that. All right. I'm going to do H. All right. Divided by a fraction is the same as multiplying by the reciprocal. Right? Now we tidy it up. A to the 4/3, 4 times 1/3 over 9, times the 4th root of 81 cubed over A. Now, once we have multiply, it's in order, yes? So I have 4/3. This is one of them, so that's 3/3. 4/3 minus 3/3 is A to the 1/3. And this is 3 because that's the cubed root, or the fourth root of 81. 3 cubed is 27. Now I have 27 over 9, which is 3. There it is as a power. 3 cube root a as a radical. And remember, we're not marking this for marks because it's so tricky. Yep. G. What's 10 divided by 5? 2. X to the 1/5 plus 3/5 because it's minus 3/5. So 2x to the 4/5, which is 2 fifth root of x to the 4th power.
Okay, there was just like you highlighted, there was something else down below it. I didn't know what your answer was because it was highlighted.
Okay.
Yeah, that's what I got. Okay.
And there is 8, and can't quite fit. Oh yeah, I can. 8 and 9. There you go. 8b. All right. What does the negative exponent do to the base? Flips it. 3c to the negative 1 over 768b to the negative 1. Now, all that to the 3/8. Now, you have some options. You could move the c and the b right now, if you wanted. Do you want to? Okay. So you're just moving the c and the b. So c, b. Now everything is to the 3/8, right? What's 3 divided by 768? That gets you 1/256th c over b, yes? Then I want 3/8, the 8th root of all this. Oh wait, I only want it as a power. So it's c to the 3/8 over. Now, 256 does have an 8th root. It is 2. So this is 2 cubed, which is 8b to the 3/8. Because that and that, the 8th root of 256 cubed is 8. But if you left it as 256 to the 3/8, I wouldn't be sad. Because I haven't reviewed yet how to properly simplify a radical. That is today's lesson.
Can you do C?
I bet I can. I'm the math teacher.
Yeah. Can you do the
So I would tidy up there first. And of course, the first tidying you have to do is right here. So you got a to the 1/3 and a to the negative 10/15 over a to the 4/3, yes? Then I would tidy that. Now 1/3 is 5/15. 5/15 minus 10/15 is a to the negative 5/15 over a to the 4/3. 5/15 is, of course, negative 1/3. Negative 1 minus 4 is a to the negative 5/3, which is 1 over a to the positive 5/3. And that's all we had to do. Again, I stress this. I cannot stress this enough. Every ounce of math you have ever done in BC is going to be in this course. Everything you have ever done. Something that Mrs. Bad Crumble taught you in grade 5 and you never talked about since is in this course. All right? Mrs. Bad Crumble did not remind you that everything she's teaching you was coming back later on. Mostly because he or she doesn't teach higher level math courses and isn't aware of what is coming back later on. Because most of your elementary school teachers, even a lot of your middle school teachers, are not necessarily math teachers. They just teach it. Everybody cool? It's not their fault. That's just the way our system works. You do the best you can. Some of you had the music teacher as your elementary school teacher, and you are spectacular musicians. Some of you had the phys ed teacher as your elementary school teacher, and you kick ass in gym class. Because every one of those elementary school teachers had a specialty, and that's what they really kicked ass at. Other than that, they were just trying to do their job. And again, it's not their fault. That's just the way we roll. Anything from 10?
Yeah.
Which one? 10F. All right. Since you see a negative there, you know this is all technically over 1, yes? So we flip it. 1 over negative 3a5 b to the negative 3. Do I even care about c? Why do I not care about c? Because it's a 1. And all that is squared. Now, is that negative part of the base? And that base is being squared, yes? So what happens to that negative? 1 over 9, a to the 10th, b to the negative 6. What there isn't allowed? The b. So where does it have to go? To the opposite spot, to the reciprocal spot, b to the 6th over 9a to the 10th. Yeah. And number 11. Oh boy is right. Do not say A, B, C, D unless you need to see A, B, C, and D. Why are you Dr. Eviling me? I have a question. A and C? All right. In the interest of my pen working, in the interest of time, can I have that there? Are you okay with that first step? I have brought the negative in because this is what almost all of you appear to do. No matter how many different ways I show you, when I show you something like this, you all seem to bring the negative in regardless. I'm not saying that's wrong. I'm just saying that's not the way I like to do it because it makes for extra steps. But if you get it that way, that's cool. Okay? Now, you've brought the negative in. Now, some of you will move all these negatives now. Some of you will just subtract or add as is appropriate. I can't read your minds, so I don't know what you would do. Personally, I wouldn't have started this way, but if I found myself here, I would move this now. I would do all my movements now. So I would get 8 squared would be moving up times 10. P to the negative 9 would be moving down, so I would get P to the 9 plus 6, because I already had 6 down there. Q to the negative 6 would move down, Q to the 6th, Q to the 10th would move up, I'd have Q to the 10th, and R to the negative 6 would move up. Now I would just do my math. 64 times 10 is 640 over 9 plus 6, P to the 15th, 10 minus 6, those 6 cancel, leaving me with Q to the 4th up there, and R to the 6th. But again, that isn't necessarily the way I would go about doing it, but it shouldn't matter, because if you do all the laws, you will end up there if you've done it correctly anyway. That was B. Did anybody even ask about B? What the hell? Why did you all let me do B? You wanted A and C, didn't you, Preston? Where? That's an A. This is C. That's A. There's a little... Clearly, those are both A's. -4 minus -2 is b to the -2. Now, if you don't like that there, you're going to move it now. Right? Times -8, a to the -2, -3, b to the -3. When we multiply, we go straight across. 8 times 8 is -64. 10 plus -2 is a to the a over -3 b 2 plus -3 to the -1. Two negatives, positive, b moves up. And C. Negative flips this whole thing. 1 over -2, x to the 5th, y to the 3rd, z to the 8th, all squared. Now I'm going to deal with that. 1 over. Negative's part of the base. It's squared. 4a10b x 10 y 6 z 16 times -2. Well, sorry. Now I'm going to tidy this up. -2 cubed is -8. X 6. Y -24, Z 36. That needs to go where? Down to the denominator. Oh, I left the 4. Then I just go straight across. -8, x to the 6th on the top, 10 on the bottom. Those 6 are going to cancel, leaving me with x to the 4th. Y6 is already on the bottom, giving me y30. 16 is on the bottom, 36 on the top. Those 16 cancel, leaves me with 20 on the top. -8 divided by 4 is -2. Z 20 over x 4 y 30. And D really has all the work there, but I'm willing to do it again if needed. Is it? If you can't follow my work on D, I'm willing to go over it again. But remember, this is done the way I would do it. Are we good? Yeah? Okay. You have a test, I'm going to say Tuesday. Test reminders. Page 27. Exponent laws. Page 8. Page 8. You need to have them locked in your head. The problem for most of you is negative exponents. You need to figure out what works for you. B to the negative 8 over B to the negative 4. You can move them both right away. B to the 4 over B to the 8, which then gets me B to the 4 minus 8, which then gets me B to the negative 4, which then gets me that. Or you could look at it as negative 8, negative 4. They're both the same sign, so I can cancel 4 of them, still leaving me with negative 4, which then gets me to here. Or I can look at it here after I've flipped them both, cancel those 4, cancel 4 of those, and of course I have to have a 1 on the top because it's not 0, because this is always 1 times that, which then gets me to there. I don't care how you look at it, you gotta figure out the way that works for you, because I've shown you all 3. 3a to the negative 4b squared c cubed, all to the negative 2. This is always over 1, so this becomes 1 over. Now here's a mistake a lot of you make. That negative 4 stays negative. The only thing that changes is this guy. Then you could move that 4. B to the 2/3 times B to the 4/5. If it was 2 and 4, you would just add them. So why would you do anything differently here? You will add them. To add fractions, you need a common denominator of 15, which is 10 plus 12, which is B to the 22/15, which is also the 15th root of B to the 22nd power. That's it. There's nothing else in this whole unit except those grade 10 exponent laws and this, which also most of you probably saw in grade 10. It is simply a matter of working methodically and paying attention to detail. Don't try to do too much in each step. There is no benefit. All right? The benefit, and thirdly, write it down. Aaron. Which brackets right where? Here? No, because it's also the 15th root of B to the 22nd. They're the same thing. The reason I show both, Aaron, is because of this. If, for example, I had the cubed root of 8, or if I had 8 to the 2/3, that would be the cubed root of 8 squared. I put the brackets when this is perfect, because you know the cubed root of 8 is 2, squared is 4. Right? If it's under there, then it doesn't matter, because it's still the cubed root of 8 squared, which is 64, and the cubed root of 64 is still 4. It is just what works better for you. Everybody good? Now, because I've ended right here, it is time to move on to our next unit, which begins on page 33, and this is again, opens with the review of grade 10. This scenario, we've already talked about this, And I have mentioned these names, but we haven't codified it, meaning we haven't written it out to remind you of what they are. A is a coefficient, which means it multiplies the next thing. And that coefficient comes from under the radical sign. X is what we call the radicand. That is the number that we are breaking down with prime factors. And that is what gives us, this breakdown is what gives us that coefficient. And lastly, n is the index. And that tells us how big a group of factors we will break the radicand into. All of this is not news to anyone. An entire radical, please underline entire radical, is radical symbol, radicand. A mixed radical is coefficient, radical symbol, radicand. Our goal often is to turn an entire into a mixed. But sometimes you need to go the other way, especially when you're simplifying things. Okay? Now, I will remind you how to do this the easiest way I can, and then I will remind you of the shortcuts that I taught you all in grade 10. The easiest way to do this, and the way that always 100% works and never, ever, ever lets you down, is to factor tree the radicand. What is the radicand here? 72. So I factor tree the radicand, and I go until I have prime factors. Do I need to remind you all of what a prime number is? They are the most powerful numbers in the universe. They are the language of math. 72, I break it down until I have prime factors. You do not stop a branch until you have a prime factor, but it does not matter where you start. Most of you will probably, because you don't remember all the little shortcuts, will probably put 8 and 9 there. That is my guess. Are either of those prime numbers? No. So you will continue to work. 2 and 4. That is a prime number. 4 is not. 2 and 2. Now I have prime numbers. 9 is 3 and 3. Now I have prime numbers. So now I know that the square root of 72 is the same as the square root of 2 cubed, 1, 2, 3, times 3 squared, 1, 2. 2 cubed is 8, 3 squared is 9, 8 times 9 is 72. What is my index here that I never write? 2, which means I am looking for groups of factors that are too large. How many groups of 2 can I get out of there? 1. So I bring out a single group of 2, leaving behind one of those 2's. How many groups of 3 can I get out? 1. So I bring out a single 3, leaving nothing there. Since these have now both moved from under the radicand, and I just reminded you that they are a coefficient and that coefficients multiply, 2 times 3 is 6 root 2. That is the longest way to do this, but it is the most reliable. You cannot screw it up if you can divide. You can't. You're in the 11th grade. I trust all of you can divide. Now, there are shortcuts. For example, since I am seeking a square root, anytime I can do a perfect square here, I can stop. So if I take 72 and I go 2 and 36, I can stop because 36 has a square root. Root of 72 is the same as 36 times 2. The square root of 36 is 6 root 2. Okay. If it was a cube root, I could stop a branch if it ended at what? A cube. If it was a 4th root, I could stop the branch if it ended at a 4th power, like 81, or 16, or 256. How do I know those? From practicing. I did not sit around when I was your age memorizing perfect squares, cubes, 4ths, and 5ths. I've just done so many of these that you start to see them. All your math teachers that you see doing math quickly, it's not because we're brilliant. We're not putting people on the moon. We've just practiced more. The same reason that when you watch somebody in the half pipe on a snowboard, they're not Superman. They were just like you, except they practiced. Or lacrosse, or hockey, or rugby, or tiddlywinks, or horseshoes, or bocce, or frisbee golf, or golf, or tennis, or. The only way to get good is to practice. And yet, many of you shirk practice as much as you possibly can and then wonder why you're not kicking ass. So, here we go. What is a perfect square that's involved with 99? Because I would like to avoid the grade, 5 factor trees. What is that? 9 times 11. What's the square root of 9? 3 root 11. Done. Literally 2 seconds. What's a square root that's involved in 25? What's a perfect square that's involved in 75? 25 times 3. What's coming out? 5 root 3. Now, 80 is difficult because the perfect square that's involved with 80 is beyond the 12 times table. What is it? It is 16. This is 16 times 5. So it's 4 root 5. But let's pretend that you didn't see that. So maybe you go, 8. 4 times 20. I got you. Square root of 4, 2 root 20. And then you stop there because all of you seek shortcuts every chance you get. Because that's how you were taught math. Instead of being taught the 9 times table, you were taught 63. Right? Don't tell me you weren't, because you all were. Of course, that is wrong, because this is 4 times 5. Out would come another 2 to get 4 root 5. You must continue till it is done. What's the one with 300? 100 times 3. 10 root 3. Oh, look, 63. We just talked about 63. What's the perfect square? 9 times 7. 1, 2, 3, 4, 5, 6, 7. 63. 3 root 7. What's the perfect square in 32? 16, but a bunch of you would say 4. But it is indeed 16 times 2, so that is 4 root 2. And 363. Oh, damn, I don't know. But it does obviously divide by 3, doesn't it? So 363, 3, 121. Why can I stop? 121 is 11. 11 root 3. Gouda? Great. Now, I remind you all, if you were in my grade 10 class, what did I tell you would be super helpful to do with perfect squares? Memorize the first 20. I even made you write it down. If you've gotten rid of your grade 10 book, you could do it again, or you could go back and find an old video. 1, 4, 9, 16, 25, 36, 49, 63, and so on, up to 400, which is 20. I can work backwards from 400 as well. 361, 343, and so on. Why? Not because I am smarter than you. If anything, your brains are better than mine, because mine has 44 years of mileage on it. You should be able to memorize those like that. Pretend it's a cheat code for Call of Duty 87. I'm very sad my PlayStation 3 died this weekend. It's redlined. Now I can't play Rock Band anymore. I know I'm a loser because I still play Rock Band, but I enjoy it. But now it's dead. And my son's like, guess we got to buy it, Rock Band 4. I'm like, no, because I'm cheap. But he just got a new TV part, so maybe he'll buy all the Rock Band 4 parts. And I won't have to. All right, you're intelligent young people. I want this as an entire radical. There's a coefficient out in front. Where did that coefficient come from? From the radicand. If there's a single 2 out there, how many 2's had to be in the radicand? 2. So this equals the root of 20. Now there's a shortcut here to help you out, but it's not a shortcut. How would I write this properly? If I wasn't being a lazy math guy and I was writing every single number that should be there, what would this really look like? 2, there's my 2, little 2, 5, right? 2 squared. This is 5 times 4. What is 4? 2 squared. Everybody see that handy-dandy little trick? So what would this be? The square root of 29 times what? 7 squared, which would be the square root of 29 times 49, which I would love to be able to do in my head, but I can't. Actually, I probably could. It's 157. 1570 minus 49 is 1530, 1521. 1421, damn. Yeah? Yeah. Now this one's tricky. It's written this way to fool you. Because you guys start looking, oh, okay, 6 squared, root 4, that's root of 4 times 36, done. That's root 144. But it isn't really, is it? What is it? What's the square root of 4? What's 6 times 2? 12. Right? And what's the square root of 144? 12. Right? And lastly, this one always messes kids up. What's the answer? This is where I find out who's thinking mathematically and who's just following steps. The minus isn't part of anything, is it? So what's the answer here? Negative 12 times 25, which is negative root 300. If you bring that negative 5 under there, you're not going to be right. Everybody understand why? Some kids say that it's this, the root of negative 300. Does that exist? No, why not? You can't have a square root of a negative number. It doesn't exist. It's an imaginary number. So it can't be that. A lot of kids say, okay, then it's the root of 300. Because when I bring negative 5 under there, it's negative 5 squared, right? But it can't be that either, because this symbol means I am on the left side of 0. So I need to have that negative still. That's why that is the right answer. Is everybody cool? Good. Now, with all the knowledge that you have, you should all be able to do number 3 right now by yourselves. Go.